Myself Prabhakaran J, working as an assistant professor in ECE department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is adaptive filter from Unit 5, that is digital signal processing applications, from the subject of digital signal processing. Let us discuss. The term filter is often used to describe a device in the form of a piece of physical hardware or software that is applied to a set of noisy data in order to extract information about a prescribed quantity of interest. An adaptive filter is a type of digital filter that self adjusts its parameters in real time to achieve a desired objective, such as minimizing error between a output and a reference signal. Unlike fixed filters, adaptive filters are algorithms that dynamically changes the filter coefficients based on the input signal and an error signal. They are especially useful in environment where signal characteristics change over time and are not well known in advance. And some of the common applications of adaptive filter is noise cancellation, that is ECG signals and audio and communications. Second thing is echo cancellation. Third one is channel equalization, system identification, and another one is prediction and modeling. These all are the some of the applications of the adaptive filter. Okay, see the block diagram of adaptive filter. The given block diagram represents the structure of an adaptive filter system, which is commonly used for application like noise cancellation and system identification. This adaptive filter consists of two distinct parts, which means which is the digital filter to perform desired filtering and an adaptive algorithm to adjust the coefficient of the filter. And in the block diagram, where small d of k is nothing but the desired input signal and y of k is the output signal of a digital filter driven by a reference input signal x of k, and an error signal e of k is a difference between desired signal and output signal, which means d of k and y of k. The adaptive algorithm adjusts the filter coefficient to minimize the mean square value of error signal, which is e of k. The optimization criterion is a cost function which is most commonly uh, the mean square of the error signal between the output and the output of the adaptive filter and the desired signal. Next, as the filter adopt its coefficient, the mean square error converge to its minimal value. At this state, the filter is adopted and the coefficient have converged to a solution. The filter output y of k is then set to match very closely to desired signal, that is d of k. Okay. Uh, Next, you can see the block diagram. X of k is nothing but the input signal. This is the signal feed to the filter, and it could be a noisy signal or a reference input signal in system environment. Okay, and another one is FAR adaptive filter block, a finite impulse response filter whose coefficients change dynamically. It process the input signal x of k to produce the output signal y of k. And then output signal y of k, you can see the y of k is nothing but the output signal. This is the current output of the adaptive filter based on the present filter coefficient and input signal. Next one is DFK, which is desired signal. This is the reference signal that we want the output y of k to match as closely as possible. And next is error signal. This error signal feedback to the adjust the filter coefficient. Next one is algorithm, adapting algorithm. This block uses the error signal e of k to update the filter coefficient in real time. Also, the common algorithm is the LMS, which means least mean square algorithm. This is simple and widely used. Next one is RLS. This is faster converged, um, but this is the most complex algorithm than the uh, LMS, least square algorithm. Okay, next one is there are two types of adaptive algorithm. First one is LMS algorithm, and another one is RLS algorithm. LMS algorithm are class or of adaptive filter used to mimic a desired filter by finding the filter coefficient that relate to producing a least mean square of the error signal. Error signal is nothing but the desired signal. uh, Error signal is difference between the desired signal and output signal. Next one is recursive least mean square adaptive filter algorithm that recursively find the coefficient that minimize a weighted linear least square cost function relating to the input signal. Okay, and next one is uh, least mean square filter. Already we discussed what is least mean square algorithm, and here you can see the block diagram of the least mean square filter. And the input signal x of n is filtered by the FAR filter to produce y of n. Y of n is compared with the reference signal d of n to produce the error signal, which is e of n. This error is used to adjust the filter coefficient in the coefficient update mechanism. Mm, the goal is to minimize error e of n, making y of n closely approximately d of n. This is the how it works. Okay. Okay, next is you do one small classroom activity. Here you can see the four triangular. First triangular values 8. It has first value is 6, 2, 2. Likewise, uh, value of first triangular is 8, value of second triangular is 6, value of third triangular 6, and find the value of fourth triangular. Okay, uh, you answer me through the comment. We will discuss the next one. See the LMS algorithm, least mean square algorithm. It consists of two basic process. First one is filtering process and another one is adaptation process. First one is filtering process. Filtering process to calculate the output of FAR filter by convolving or multiplying input and taps. and a filtering process to calculate the estimation error by comparing the output to desired signal. This is the filtering process. And second thing is adaptation process. This adjust tap weight based on the estimation error. Okay, and next one is uh, we will see recursive least mean square, which means it is an adaptive filter algorithm that recursively find the coefficient that minimize a weighted linear least mean squares um, cost function relating to the input signal. And here you can see the block diagram of RLS filter. And working principle is the output x of n passes through the variable filter and producing an estimated output, which means which is represented by d cap of n. The error signal E of n is calculated by comparing d cap of n to the actual desired signal d of n. This error is fed back to the updated algorithm, which adjusts the filter coefficient to minimize further error. Over time, the filter learns the characteristics of desired signal and it improves its performance. This is the working principle of RLS filter. And next one is the assessment questions for this lecture. And first question is define adaptive filter, and second question is what are the applications of the adaptive filter, and third one is what are the types of adaptive filter algorithm, and another one is mention the two basic process of the LMS filter. These all are the assessment of this lecture video. If you have any doubt, you can ask me through the comment. We will meet in next video lecture. Thank you.